Hello and welcome to episode 228 of our SAP on Azure video podcast. Today is February 7th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So a few weeks back, we had Evren Buyruk on our show where he started to talk about networking and security. Since he could not spend a lot of time on this topic, we decided to have a deep dive. So today, Evren, together with Daniel Mauser, who I just learned is the king of networking and security, will share more insights on Azure Vnet encryption and show us some cool, impressive demos. So Evren, Daniel, welcome to our show. Evren, welcome back for...
Thank you.
I don't know. Much. It's the sixth or seventh time or something like that.
This is the seventh or eighth, maybe. I don't know.
Eighth, maybe. Okay.
I'm sure that seven is guaranteed, but 8 is tentative.
I think Holger, he's slowly pushing us out, from this.
Yes.
He's overtaking, the show here.
So about Evren, for those folks, or Evren and Daniel, for those folks who don't know you, maybe you can quickly introduce yourself and tell a little about what you're doing at Microsoft.
All right, let's start with Daniel then.
Yeah, so Daniel Mauser, Azure networking specialist. I'm part of a team called Global Black Belt, and my goal is always to capture customers' challenges on networking and bring solutions for them. And that's what I do, and I love to do networking. Thanks for having me again. That's my second time here.
Yeah, you're right. You're right.
And
Evren.
I am Evren Buyruk, that you guys already know me. I am with International Customer Success Unit, and I am assigned to SAP Americas and SAP line of businesses. And then I help this customer with their Microsoft Azure implementation, and then their their growth on Azure around networking and security. I also function in the internal Microsoft SAP connected SAP on Azure connected community. I've been leading it now for quite a while, and I also just make sure that our internal cloud solution architects are getting the latest and greatest around SAP on Azure. So we've been actually just partnering with various program managers and product groups and cloud solution architects, and we give them a stage for around 60 minutes every month, twice a month. And then we educate other cloud solution architects to apply the learnings into their day-to-day customer interactions. So, and today that we are very excited about the Vnet encryption that we've been actually just discussing quite a while. And last time that Cameron Gartner and myself, we actually just appeared on the YouTube channel for SAP on Azure that you guys have been meticulously leading for quite a while. I think that was like 4 or 5 years now. And so during that presentation, we actually just unlocked the encryption, and Cameron Gartner did a fantastic job around how the encryption around databases actually just work on Azure, and then with the performance metrics, and he did a phenomenal job. So I had a very little window to speak about that the topic of Vnet encryption, which is something that I will say that is replacing the technology requirements and needs for intra-DC encryption. And when the solution actually just came about, I had a chance to actually just literally look into it, test it, understand it, find out. And then, but it wasn't something that was really just deep dive into how the customers were really just applying this technology until I started work with Daniel. So what he did, he actually replicated very, complex customer scenarios into his lab environment, which I was I was amazed at the quality of the work that he did. So now everything that we put together today is just going to be corresponding to the demo that is going to be shown, by the mid, times of this session today. So if you allow me, I would like to share my screen, and then we can get this started.
Yeah. And just to continue what you just said, so we had the session with Cameron where we talked about the impact of encryption to performance, and I think Cameron could beautifully show that um, there is some very small impact, but the recommendation is very clear to enable all these different encryption layers. And at the end, as we said, it would be great to have a deep dive on some of these topics on the Vnet encryption, and that's why it's great that you're here back with us, Evren and Daniel.
Yeah, I mean, I'm really very excited. Again, this was the topic that we actually just we really look forward to. We really want to actually just like meet with you before it's too late, because we know that customers have been really looking forward to getting some technologies from Microsoft to achieve the intra DC encryption, VM to VM communication, and to make sure that some technologies can be provided by Microsoft, such as technologies like DTLS, datagram, TLS, which is going to be something that I'll be actually I'll be talking about that briefly about it. So again, today's session is going to be on virtual network encryption. What exactly is it? And then the demonstration part on that. So, and then I would like to say that before I actually just start, Azure Virtual Network Encryption is now generally available in all Azure public regions and is currently in public preview in Azure Government Cloud and Azure, Microsoft Azure, operated by 21 Vnet. So these are the availabilities today, but for the public cloud, it is available in every region today, which is a great thing because some customers, they needed to know about that because they're actually widespread across the world, as we have around like more than 50 regions today, and then a lot of region availability. And now in all those region availabilities, we have the Vnet encryption available. So what exactly it is? So I would like to actually just like mention about the Azure FPGA, which is actually a term that is referring to the use of that field programmable gate arrays. FPGAs in Azure is provided as a service. Basically, this is the hardware devices that can be programmed to excuse me, perform specific tasks such as like AI, inferencing or software-defined networking. What it does that Microsoft with this technology offers a hardware as a service solution called Azure Stack Edge with Azure Edge Pro with FPGA, which is allowing our customers to use a cloud managed device with a built-in FPGA. So Microsoft also uses this FPGAs internally, and then we are powering our network and some of our services as well, such as like Microsoft Bing and also Azure Cognitive Services are also leveraging the FPGA. So now the question around how Microsoft actually just achieves some of the technologies around cognitive services, AI, inferencing, for example, it is going to be FPGA, which is something that we might actually just show, a few slides and some technical. I believe that Daniel might actually just show something around that. So I'm giving you a heads up, Daniel, just in case, you might want to actually just show that hardware. So basically, Azure Virtual Network Encryption is a feature of Azure Virtual Networks. So when I say Azure Virtual Networks, when you are creating yourself a VNet address space, and then you actually just start a process. So what it does with the virtual network encryption, again, which is the feature of Azure VNets or virtual networks, it is allowing you to seamlessly encrypt and decrypt the traffic between virtual machines by creating a DTLS tunnel. So when I say the DTLS tunnel, this is the datagram transport layer socket or security, I will say. So what it does, it is enabling you to encrypt the traffic between these virtual machines and even the next generation architecture component, or I will say the replacement of the availability sets construct virtual machine scale sets. So it is doing the encryption between the virtual machines, even the virtual machine skill sets within the same virtual network. So this is the key. When the customer has the Vnet enabled, it is going to be their Vnet. It is going to be the technology is going to be like the hub and spoke topology, for example, hub being the central point of connectivity to the spoke network. Your hub Vnet is going to be your Vnet, your address space. Encryption is going to be enabled in that Vnet, in the Vnet of the spokes, and then you're going to be achieving this, intra VM encryption. What it does, it is going to be encrypting the traffic between regionally and globally, peered virtual networks. So there is a reason why we have this slide just showing that it's not only about that same region, it is going to be across regions as well. So what it does, virtual network encryption really enhances the existing encryption in transit capabilities in Azure, which we are doing it like from TLS point of view, that when a storage account is created, AES 256 is enabled by default. It is a data at rest encryption. You're covered on that. Now you're covered on the TLS, which is going to be transport layer socket between two VMs or between two corresponding hypervisors, which are spread across regions, but you enable the DTLS with the Vnet encryption. In other words, when you are actually just enabling the Vnet encryption, DTLS is enabled automatically. So there's some like limitations, such as not limitations, I will say dependencies. Excellent networking, for example, must be enabled on the network interface of the VM. So all the VMs behind internal load balancer must use a supported SKU. So we actually just put some SKU names here: D series, E series, V4, V5, M series. And also you can find all the supported SKUs on Azure, even when you actually just type Azure Virtual Network Encryption on your browser and then supported SKUs, it just shows you the entire list of the SKUs. So these are important is because, customer really needs to find out what SKUs they have. If not, we can actually just get them over to certain VM SKUs for them to actually just leverage this technology.
Yeah, if I may just jump in.
Yeah.
Basically, DNE series 4 and 5, it's supported by SAP M series as well.
All of them.
If they have something lower than V4 and V5, they can always resize this to the upper one, which is always recommended. And VMSS Flex is a kind of what we are generally pushing from a HA perspective, so to say, and distribution. So meaning customer is good to go here, nothing, it's a showstopper here, I would say.
Exactly. And also some like, compliance details are PCI, HIPAA, FedRAMP in the context of Azure. And then there's also a hyperlink available. So also the Azure public guidance for FIPS 140, there's a link available, so the audience can actually just like, go there, or they can just type it on their browser exactly what it is, the Azure public guidance for FIPS. They can, stop this presentation right here, get that wording, or, naming conventions, just put it on their Bing or their browser of their choice, and they can actually just find those, details. So DTLS tunnel with virtual network encryption. So as you guys remember that in the previous slide that I mentioned about the Azure Virtual Network Encryption is a feature of Azure Virtual Networks. In other words, it is the technology allowing you to seamlessly encrypt and decrypt this traffic between Azure virtual machines by creating a DTLS tunnel. So again, I mentioned about DTLS, what exactly it is. Datagram transport layer security is the communication protocol which has been designed to provide security for datagram-based applications. So datagram-based applications is still, this technology is still based on the transport layer security TLS. It is still on the same protocol, which is widely used to secure communications over the internet, but is now adapted to work with connectionless transport protocol, which is something that user, datagram protocol UDP is actually just like, leveraging. So in this, you can immediately just think about the UDP and UDP amplification attacks. What exactly Microsoft does around it. So yes, we have the Azure DDoS, network level protection for the UDPs, UDP amplification attacks, or to secure the UDP protocol. But in the same time, with the datagram transport layer security, that we are achieving connectionless traffic transport between two VMs, and then you're making sure that your UDP is also just protected by that. So the blue diagram that I'm putting here in this screen is actually illustrates the process of DTLS. So what happens is that the client starts the request and send it over to the server. The message initialization contains that information about that client. It is actually keeping in the cache, such as those that information around the capabilities and security settings, which has been actually just pre-created or predefined. So then the server encodes that data, which is received into the compressed format and encrypting it. So the process is actually just like the encryption and decrypting it seamlessly. So is the customer going to have to just do it? No, they just need to actually just start a process and start just use it. So then the server is going to send an encrypted message to the client. It's going to be, achieving the data privacy. So then the DTLS is overall going to help secure the data exchange and communication between the client and server technologies without being manipulated or even forced, I will say. So like the spoofing, for example. So it is going to ensure the reliable transport layers. It is going to have the mechanism to handle all the problems in the network, and it is going to cater unreliable transport layers. And then is going to be also just providing the security for information, transfer over the internet as well. So like when you are looking at the DTLS, it overall, the security for the UDP, as DTLS is specifically designed to secure communication that use UDP, which does not guarantee the delivery of the packets, order, or even error, correction, or error, improvements, I will say, or corrections maybe that actually just fits better. TLS is based on that connection-based communication, but what DTLS does, it actually, complements the TTLS's missing, missing component, which is actually the connectionless, packet delivery. So this is actually even making the, DTLS suitable for applications like even, video streaming, online gaming, voice IP, and other real-time, communications where low latency is critical. So now thinking about customers have been leveraging technologies like Microsoft Teams and Microsoft Voice IP technologies. It is also additional component to secure the communication as well. Not only for the SAP workloads coming in and out, or the technologies that depending on VM to VM communication, like the app server to database server communication. This is going to be widespread. It's going to be covering a lot of technologies that customers actually just leverage, because DTLS is providing this confidentiality through the encryption, and it's ensuring that the data transferred between the client and server is protected at all times, which also leads to integrity, as the integrity is also provided by DTLS, as it is ensuring that the data integrity by using. So now maybe Goran is gonna say, is that the same Mac? But it is actually just using this message authentication codes, MACs. It is not the media access control MAC, which is IEEE standard. It is using the message authentication code to, why is that using it? Is actually the codes to verify the data has not been tampered with anything during the transmission. I think this is the key component. So how it does, it is doing it with the codes, which are actually just hidden in the DTLS technologies or DTLS features. Also is avoiding the TCP meltdown problems, as well as the TTLS is happening on the DDoS level and does not affect the TLS protocol. So naturally, TLS meltdown problem is avoided when you actually have the DTLS, because it's no longer actually just a matter of it. DTLS is actually avoiding it. So then the authentication part is also just like important as what it does when you actually enable the Vnet level encryption. DTLS takes in and then supports various authentication, methods to verify the identity of the communication parties, which is essential for establishing the trust, which is which is something resilience to the packet, in packet loss, and also protection on the UDP communication. And this is actually support scenarios that I'm just going to be actually just speaking, very briefly about this, so we have time for the demo. Basically, virtual network encryption support scenarios is just like as you guys see on the screen, is the feature, since this is the feature of the Azure Virtual Networks, and is going to be actually just providing you a lot of, I would say, capabilities around Azure Kubernetes services from security point of view, global virtual network peering, and then also it is going to be supported on AKS using Azure CNI. It is regular or overlay mode, Kubernetes, and then is also partially supported on AKS using Azure CNI, dynamic pod IP assignment, and then traffic to the AKS managed control plane egress from the virtual network. And then this is something that actually needs to be identified. This is the only component to the technology that the traffic to the AKS managed control plane egress from the virtual network is actually not in the scope for virtual network encryption. So this is the overall support scenarios for a lot of customers to know. It is for the VM SKUs that they need to actually just be factoring in to enable the virtual network encryption, and then they need to actually just check, such as the technologies like accelerated networking, for example, needs to be enabled, and the customer is going to be good to go.
And especially as we're just saying, for SAP, this is a perfect prerequisite, or for SAP customers, this is a perfect prerequisite, because most of the things are most likely already in place. They have the right SKU, like an M series or D series, exactly what Gordon was saying also as well. And then I think also network acceleration is also something that we very much recommend. So I think this looks like a perfect fit.
Exactly, and also so sometimes some customers are asking, hey, I'm going to enable this. What is this supporting? What is not supporting? So the thing is, this technology is free. So and Microsoft actually designed this technology to address many requirements of customers. And then majority of our customers, they actually just want to find out VM to VM encryption is enabled at all times. And then this encryption is using technologies like DTLS for connectionless packet delivery. And now we have this technology for SAP workloads. And then we have one large customer who actually adopted the Vnet encryption after we showed all the technical capabilities around this technology, and then the corresponding demo that we ran, and then customer confirmed that this is going to provide them with end-to-end encryption intra DC across regions, and they're actually just now moving forward with more implementation and deployments on Azure. So one thing that we need to know, that this is actually a very handy slide, basically the limitations perspective. So some of those components, such as in scenarios where PaaS is involved, the virtual machine where the PaaS is hosted dictates if virtual network encryption is supported. The virtual machine must meet the requirements. Like the same thing that I said earlier, it is the SKU that is going to be very important. So it needs to be checked if the SKU is supported. If not, we can move the customer to the right SKU. So for internal load balancer, all virtual machines behind the load balancer must be supported virtual machine SKU. Is also, like you guys see, that it is all boiling down to the SKU. And then if the SKU is actually supporting it, then we are just going to have these interdependencies already identified and customer can set assured. So during the demo, when we actually just show how we do it, it is going to be a game changer for a customer who is thinking about, deploying this Vnet encryption, because we're going to be touching on many of those components. So the option, like the number 3, allow unencrypted is the only supported enforcement and general availability. Drop unencrypted enforcement will be supported in the future. So this is going to be announced down the road. And then the other one is the virtual network with encryption enabled. Don't support Azure DNS private resolver. It is also just going to be in the works. We don't know the timelines, but these are all going to be announced. Virtual networks configured with the private link service don't support virtual network encryption. So the virtual network encryption shouldn't be enabled on these virtual networks is something if the client is leveraging Azure private link service. So then this is not going to be the right technology for them to enable. And then the last one is the backend pool of an internal load balancer must not include any network interface secondary IPv4 configurations to prevent connection failures to the load balancer. And then we also have tips. These tips are actually the tips that we're going to be showing in the in the presentation during the demo. In this presentation, while we're running the demo, basically we're going to be actually just like showing what we are doing to enable it. So it's just going to be actually very handy for the audience. And this is actually tips on Azure Virtual Network Encryption. And then this slide really highlights about what we're going to be doing in the demo. This actually illustrates the demo, which we're going to be actually just running. So again, like I mentioned, that virtual network flow logs, I need to actually just touch base on that. This is something that we need to be, making sure that customer leverage virtual network flow logs, and then customer integrates the flow logs with the traffic analytics. The reason why we are actually just doing is that if the network flow logs are enabled, so then customer can use them to log information about the IP traffic flowing through a virtual network, which we actually just did it. We animation here that you guys can actually just see the traffic flow through the virtual network. So the flow data from the virtual network flow logs is sent to Azure storage. So what it does from there, you can access the data and export it to any visualization tool. So you can actually just find out about the security information and event management SIEM solutions, and you can do the integrations from there, from the storage to those to actually enable visualization for yourself. So specifically, I want to actually just say a few words about that traffic analytics. The reason why we're actually just having it is because it is analyzed in the Azure Virtual Network flow logs so that it provides this insights into the traffic flow in the Azure Virtual, Azure Cloud. Basically, customer actually just do this to visualize the network activity, across the Azure subscriptions. They can even identify those hotspots. They can secure their network by using information about that identity, threats such as open ports, applications that attempt to, access the internet. And then you can find out when you find out about those applications, access into the internet, and then is the topic for the, gateway last resort, GLR. You can identify some GLR plans. So to make sure that what VMs are accessing internet, what, applications are accessing internet, you can also do some logging on those to audit, those access points. So with the traffic analytics, you can also optimize the network deployment for, the performance. You can do that for capacity to understand the traffic flow patterns. So now I'm giving an answer to those customers who would like to actually just, optimize their network for performance. So everything that I said here is actually just addressing their performance requirements and how to actually just achieve it. The traffic analytics is going to actually just, give one component so they can pinpoint those network misconfigurations that can lead to failed connections in their networks. So with this, I'm actually advertising the traffic analytics while we were talking about Vnet encryption, I just want to actually just like, give some tips so customers know this is not the only technology we have. We have a lot to offer. And this is the draft Vnet, for architecture. With this, I'm actually just going to be, I'm going to be turning the presentation over to my colleague, Daniel. So this is the technology, everything we actually just said in this presentation. This is the illustration of it in one slide. And then what we're going to do is now, during the demo, everything is just going to be, making sense, because we have the virtual network Vnet already just like, created. We have the VM to VM communication between two Azure hosts is going to be actually communicating with each other, leveraging the FPGA, field programmable gate arrays, and then accelerated networks enabled on the SmartNICs. And then the technology flow is going to be actually shown to you with the demo. And I know that I spoke a lot. Now, Daniel, I turn it over to you.
Thank you, Evren. Yeah, this is just an illustration to visualize better how it works, the technology behind the scenes. So in the first section of this draft, you can see that we have the Intra Vnet example. I think we can move to the. Actually, that's good, Evren. Leave this, because this is the lab that we're going to cover. And I'm going to share my screen with all the technical details.
Exactly, exactly.
So
you if you like, you can actually take over the presentation, or you can share your screen if it is okay.
Okay, yeah, let me take over. Yeah, exactly. So so for the lab, exactly what you see here is what I'm going to demonstrate. And the good news is the audience that's watching this, they can try themselves, because everything that I'm showing here is in the GitHub. You can deploy exactly this environment that's you see on the screen. And what I'm doing here is on the right side, we have a typical hub and spoke. And on the spoke one on the top right, we have two VMs to illustrate the Intra Vnet encryption. On the hub Vnet, we do have an NVA that's kind of what typical customer is going to have, some sort of a firewall, a router, and it's to illustrate the Inter Vnet when the communication leaves the spokes VNets going towards the hub VNet, or there's a communication between spoke 1 and spoke 2, which my NVA is interfacing. And that's the goal of the lab. The goal of the lab is to demonstrate those typical common flows what our customers have on the environment. On the left side is just like emulation of on-premises. Obviously, not leveraging in on-premises the Vnet encryption, because it's an Azure feature, but this is going to also give the customers the opportunity to. So we build on this lab on-premises. We start to do some traffic, and we're going to see also that some of the traffic, when it hits the VPN gateway, leaving the VPN gateway towards the target workload, is going to also get the Vnet encryption, and that's what I'm going to demonstrate on the lab.
And also, Daniel, one thing that if you actually go back one slide,
Sure.
You guys might remember about the IPsec over express route topic that I actually just covered a while ago. So think about the customer wants to even augment this to make sure that they would like to have two-layer protection connecting to the hub, which is the central point of connectivity, which is in the middle. Hub NVA Vnet is the hub, which is the central point of connectivity to the left side, which is going to be on premises, right? So enabling the express route, and on top of that, doing the IPsec over express route is actually just going to be augmenting that connectivity to the hub. So now the question from customers, they usually come, okay, this is just going to be providing me with the security encryption between my VMs in the same Vnet, or across spokes, or hub to spoke communication. What about my connectivity to Azure? Then enable IPsec over express route, and the problem is solved. Just wanted to add that.
Thank you. Yeah, and the scope of the, like Evren mentioned, the scope of the Vnet flow logs is going to be the tool to kind of map, because the only way you can find out if the Vnet encryption is enabled on the flow, you have to enable Vnet flow logs. And we're going to also show that during the demo. The lab that I making available, I'm going to share my screen in few seconds. It builds the whole thing for us and also enables Vnet flow logs. And I'm going to kind of walk through the setup that I have in the Azure portal. And another thing that I want to highlight is this architecture, right? Just you kind of can see from a customer subscription perspective, when you have the Intra Vnet, what happens is from an Azure backend perspective, VMs, they are obviously hosted in different Azure hosts, right?
Yeah.
And from an Azure host perspective, we do have this smart NIC, which is a hardware component. I added a paper in the GitHub that I'm going to share with you. If you want to kind of see a picture of a smart NIC, we do have more details there from Microsoft Research, which explains this this technology better. And the smart NIC has this kind of separated processing to facilitate the accelerated networking. And in the same smart NIC is where we're doing all the offloading of the processing of the encryption as well, which means it's totally transparent from the VM. It doesn't affect the host CPU per se, because everything is concentrated on that FPGA smart NIC.
And that's then, super important, because
go ahead.
If I mean, that wouldn't be the case, we would need the CPU from the VM, meaning impact the SAP performance. It would be less compute resources, and that's great. Yeah.
Yeah. And that's the illustration for the Intra Vnet is the same, right? The only difference here, we do have the Vnet peering, Vnet 1, Vnet 2, but the construct of the FPGA is about the same. So the VM talks directly with the FPGA using this technology, that's this SRIOV. If you want to go, that is more technical. That we do have the acceleration networking that happens right at that. The DTLS encryption happens between the FPGAs. So no any type of minimum, I would say, minimum impact on latency, or almost like zero, because everything is offloaded to the Azure platform. With that, let me go over my lab, and I'll walk through. I'm gonna share my whole desktop. Let me know if you can see it.
Yeah.
Yes.
So this is the lab that I'm going to walk through. I'm going to just show you a few points that I'm enumerating here. All the documentations that we have in the Microsoft public side about Vnet encryption. Very important to take a look, because there's a couple limitations. I kind of highlight important takeaways about some limitations that we have with what Evren already said about Azure DNS private resolver, and also just highlight in this lab specifically, I'm using a D2 V4, which is compatible with the accelerated networking in Vnet encryption, and just to kind of using really a small size just to minimize the cost, because the goal here is to test the feature. And also like I mentioned, I'm linking to specific papers about what's acceleration networking, what's the smart NIC is a PDF from the Microsoft Research. And there's also a video that I included here with a demo for an accelerated networking, what Marcos Honovich goes over the technology, and is an old video, but really insightful on how the technology works. And I just I added the same, I did a couple modifications from your slide, just to add the SRIOV, which is the technology that allows the VM to access the smart NIC directly on the FPGA. So the same diagrams that you see in the presentation is also present on the lab. And that's the diagram, the lab that we showed you earlier. So this is on some traffic flows that I need to generate the traffic flows in order to populate in the Vnet flow logs. That's another important thing that we need to highlight is I'm using like TCP/22 because the VMs that I'm using here, they are Linux, and I'm just it is SSH. I'm just doing like probes on 22 with netcat, and you're going to see in just to show you the difference between one is not encrypted and one is encrypted. So when you build the lat scenario, you can run everything over the Azure portal. You can also clone that repo, and I'm going to show you my view. If you clone the repo, you can have the opportunity to do everything over Visual Studio. You have all the diagrams that you see in the repo, draw.io. We do have also all the scripts that you see there. They are also listed with each step that you have to do if you want to do over the Visual Studio. Also, if you want to access the VMs over Bastion, we do have a script here where you can access each one of the VMs. As you see down below, I have like a SSH already open inside my Visual Studio where I'm accessing directly each one of the VMs inside the lab. And so the goal of this lab is kind of show you, I already run the lab. Obviously, I did the deployment. The goal here is you can test it. If you have any feedback, feel free to send over the repo. And what do we do first after you deploy the lab? You're going to generate some traffic. We do like on the Spoke 1 VM, we send towards the hub VM. We send like a probe on 22. And the goal here is to kind of show you before you enable accelerated networking, before you enable the network encryption, the Vnet encryption, you're going to head over to networking traffic analytics. You're going to open the log.
Yeah.
And the goal here is I put like a sample if you want to do some filtering. And the goal here is to show you that before we enable accelerated networking and the Vnet encryption, the flow log is going to show you all my probes that I started on those VMs. They are unencrypted.
Yeah.
In the step 3, what are we going to do? We have a script, which what it does, the script is going to enable accelerated networking in all the VMs. And that's another important factor. If you have a VM that supports accelerated networking and doesn't have an accelerated networking is required. And so which means you need to enable it. To enable Vnet encryption, you can do over the portal. It's very simple. I can show you here. This is what you get when you deploy the script. And as an example, when I go to the Vnet level at the hub, if you want to kind of enable the Vnet encryption, you have to hop over the properties on the overview properties. And in this case, in security, you're going to see encryption, which I already enabled. And you can go here, check and unchecked. So when you want checking and unchecked, what happens is if you have an existing VM that is already created, even with accelerated networking, in order to commit the Vnet encryption, that existing VM requires you to do a stop deallocate, and you need to bring that VM back again.
Okay.
If you're doing a new deployment, obviously, if you have the Vnet encryption and you in the new deployment you already enable the accelerated networking and you have Vnet encryption, you don't have to stop deallocate. It's just for existing VMs. It's required to stop deallocate in order to commit to the Vnet encryption side.
But I could already, like during runtime, I could enable or check the flag at least that it is enabled. And then once I deallocate and allocate again, then it's really active, so to say. Then it's really being used. But I can set the flags already before.
Yes, you can set so if you're like a greenfield, like new deployment, new Vnet, you have like a Terraform, you can kind of do the full provisioning. You don't need, because the time that the VM is going to start is going to catch the Vnet encryption flag and it's going to start to use it. It's just for existing VMs. If the customers today want to do it, it's mandatory to do, and that's covered on the public documentation. Make sense?
Yep.
And just show you here, if you like to do over the Visual Studio, like I said, I do some probes on the, so what I'm doing, also, I include like in all the validations, some descriptions that you can do in order to for example, you create the probes, what the direction in each VM you have to run, what the log analytics query they have to use. Keep in mind that log analytics, every time that you do it, it takes around for the first time of the setup, it's going to take about 20 minutes to get populated. But when you transition from non-encryption to encryption, it takes around 10 minutes. As a part of the lab, just to show you, this is the Vnet log analytics. It's important when you do traffic analytics. Actually, let me back up a little bit because the flow logs is configured down below here. Part of the lab, we already enabled for each one of the hub, Vnet, Spoke 1 and Spoke 2. And if you take a look inside the Vnet flow logs, we, like Evren has mentioned, the Vnet flow logs are, it's required a storage account where you need to send the Vnet flow logs, which means from the storage account, the customer can use other tools if they want to plot that information and have another visualization about it. But if you want to do it, in our case, we're doing traffic analytics. So for the traffic analytics, what pretty much we're doing is we create a log analytics workspace. And what the traffic analytics is going to do is going to grab the information for the Vnet flow logs that is in storage account, and it's going to plot that to the log analytics. And that happens in every 10 minutes. So that's why when you make that change from non-encryption to encryption, you have to wait about 10 minutes to get that information inside the log analytics.
And also, Holger and Goran, we also recommend disabling the network security group flow logs before enabling the virtual network flow logs on the same, underlying workloads. The reason why that we are avoiding this duplicate traffic recording and even additional costs when you have them like, both, or in other words, like if you enable network security group flow logs on the same network security group of the subnet, then you're really enabling that like, virtual network flow logs on the same subnet or the parent, virtual network. So that actually leads to duplicate logging, or only just virtual network flow logs is actually the reason why we actually just say the solution should be. They should not be enabled at the same time. Only the virtual network flow logs should be enabled.
Yeah, and just to highlight, Evren, the NSG flow logs are going to get retired in favor of the Vnet flow logs, because the cool thing for the Vnet flow logs, you don't depend on the messages anymore. It's a Vnet level that you enable, so it doesn't matter how many subnets you have. So in also the Vnet encryption, you can only check only the Vnet flow logs. You cannot double check if Vnet encryption is enabled using the NSG flow logs. Just want to highlight that. And after you have that, so you're going to head over to the log analytics. When you go to head log analytics, it's going to default by NSG flow logs. You need to change to Vnet flow logs. It's going to, in your lab, it's going to pick obviously the log analytics that are associated. So, and then we can launch this search log, and you can copy and paste that information because it's going to get the standard Vnet flow logs over here. And I already have one open with the sample. what I'm showing here is I'm doing anything that contains the source 10.1.5. If you go back to my GitHub and go to the diagram, so the 10.0.1.5 is the Linux VM1, and I'm doing a probe towards the 10.0.0.4. And if you go back here, the probe, and you see, actually, this is the Intra Vnet. It's doing from the 10.1.5, just go back here to the 10.1.4, just to show the Intra Vnet encryption. And moving back to the logs, you see that at some point, when I enabled the lab, it was unencrypted. After I enabled the accelerated networking, enable the flag of net encryption. I did the stop delocate, and now it shows that flow encrypted for the Intra Vnet. And you can play with the other as well. If you want to go, for example, I want to see the probe that I do from the spoke. Let me just do the filter here. So this is the VM. If you head back here, is the 10.0.1.4. And we do a probe against now it's going to show the Inter Vnet because I'm doing the probe against the hub NVA. And when I go to you're going to see that's the flow type is Inter Vnet, and the same concept I did before, which shows unencrypted and encrypted afterwards.
Nice. Cool. And these are all the goodies from Azure that customer can just use it, right? Out of the box.
Correct. And then just show you here and that's another important thing is why I'm doing, if you do just like a regular ping, that's another. So the accelerated networking favors, I would say, TCP and UDP flows, and that's why you need to, in this case, I'm just doing like a netcat to probe the port 22, which is by default enabled on Linux VMs, just to trigger that flow to show in the log analytics if the traffic is encrypted and or not. And that's kind of a highlight of the lab, and I encourage the audience to play with the lab in the GitHub. You can leave the link on the show notes.
Absolutely, we'll do that.
And that's it.
Nice. No, this is great. This is great, and it's really nice that you have this lab, so I can easily get started. I can experience. I can play around with this. I can see that it's working, and then I can also do it in my SAP environment. And why I was asking, obviously, you don't restart your SAP system all the time, but you could already prepare everything now. So really check the flags, and then once you have a downtime, that's exactly where you can deallocate, and then afterwards, everything should be, or the traffic should be encrypted. So really nice.
And no cost.
And no costs, exactly.
And
so that's really good.
Performance impact.
Exactly.
Yeah.
No performance impact, and because in the previous episode we were talking, it was a lot of context of impact on the performance of a different encryption, which we don't want to have it, right? And this is not causing the performance impact, and this is really...
Daniel and I were in a call with very important customer. 2 questions came overhead on the price and performance.
Yeah.
When we said,
of course,
there's no cost and there's no performance impact, and then more people came in the meeting. They were all just forwarding the meeting invite to others. Come over. There's something free and great.
Perfect.
Excellent. Yeah.
Well, Evren, Daniel, thank you so much for these insights. Thanks for the demo. Thanks for the introduction.
Thanks for having me.
Thank you very much
for
having us.
I'm sure we'll have you again on the show.
Thank you so much, Olga. Thank you so much.
Thank you, guys.
Thank you, Daniel.
Bye-bye.
Thank you. Bye-bye.
Bye.
Bye.